Here in this video, we are going to see the effect of voltage, current and power when an alternating current is passing through a resistor. Okay, for this we can simply draw a circuit, and here you can see an alternating circuit which will provide alternating current or voltage to the circuit. Whenever the voltage is supplied to this circuit, then the current I will flow through this, and R will be the resistance of this resistor. Okay, E or V, or we can represent simply small letter V, and this V can be equal to Vm sin omega t. Vm sin omega t is the voltage which is supplied by this AC source, and at this time some current will flow through the circuit. And what will be the value of current? We can divide this voltage by some resistor, that is R here. So V by R is equal to Vm by R into sine omega t. Okay, divide this R in both sides, so we will get this, and V by R will be equal to, what will be that? I, that is I is equal to, and Im by R will be equal to what? Im. Vm by R will be Im, so Im sine omega t. So Im sin omega t will be the value of current that is flowing through this circuit when the voltage V is supplied by this AC source. And what will be the opposition of offered by the resistor R? That will be R is equal to this voltage by this current I. Okay, next we can discuss about the phase difference between this voltage and current. In this equation, V is equal to Vm sin omega t. Omega t is the term that represents the phase. So the voltage V has some phase at the time t, that is omega t. Okay, at the time of t, the voltage V has a phase of omega t. At this same time, the current I will have a phase omega t. So the phase between this voltage and current will be the same. That is, here at the time of t, the phase is omega t in the case of voltage, and at the same time of t, the phase in current, that is omega t. So there will be no phase difference in the case of voltage and this current. So in the case of a pure resistor, when an alternating current or EMF is passing through this element means this resistor, some current will flow through this, and the phase difference between this current and the voltage will be the same. That means the phase difference between this current and voltage will be zero. They are, otherwise we can say that the current and voltage in the case of a resistance or a resistor, that will be in phase. Okay, simply we can say that they are in phase with each other. If the voltage increases, current will also increases. If the current decreases, if the voltage decreases, the current will also decreases. So based on this, we can draw a waveform for this. This can be this y axis will represents the voltage, and the x axis will represents time, and this will be the as cycle, an alternating cycle, and this cycle represents what? The voltage, the supplied voltage. And what will be the value of current? It will be starts from the same point of that of the voltage, but some difference will be here, because we will get the value of current by dividing this voltage by this resistor, so that we will get the value of current like this. But the point is that the current will starts from the same point as that of the voltage, and the current will be maximum when the voltage is maximum, and the current will be zero when the voltage is zero, and the voltage will be negative maximum, the current will be negative maximum as the same that of if the voltage is negative maximum. Okay, the current will be the negative maximum and the voltage is negative maximum, and so and so. Okay, these are the important things. And next we can think about the power for the entire circuit. Power. What will be the power for this entire circuit? That power can be the product of this voltage and this current. So P will be equal to V into I. What will be the value of V? That is Vm sin omega t. And what will be the value of I? This I is equal to Im sin omega t. So we can written as Vm sin omega t into Im sin omega t. In the next stage, Vm Im into sin square omega t. Okay, sin omega t into sin omega t will be sin square omega t. And there will be an equation for sin square omega t, that is sin square omega t is equal to 1 minus cos 2 omega t by 2. We can use this equation instead of this sin square omega t. So in the next stage, Vm Im sin square omega t will be 1 minus cos 2 omega t by 2. Okay, what will be that? Vm Im by 2 minus cos 2 omega t into Vm Im by 2. And in this equation, this will be the constant part and this will be the fluctuating part. For the complete cycle of alternating current, the average value of this terms, this entire term will be 0. So that we will get P is equal to Vm Im by 2. And we can simply written as Vm by root 2 into Im by root 2. What is this Vm by root 2? It is nothing but the RMS value of voltage. So that can be represented as capital letter V, and Im by root 2 is the RMS value of current. So that we can represent it as I. So the equation for power in a pure resistance or a resistor will be P is equal to V into I. So these are the major things about a resistor when an alternating current is flowing through this. What are they? When we supply a voltage, some current I will be flows through the circuit. The voltage will be Vm sin omega t. Current will be Im sin omega t, and the opposition resistance will be V is equal to R is equal to V by I. So that based on this phase value, that is omega t, we can simply say that the phase difference between this voltage and current will be the same for an AC circuit, means there is no phase difference. Phase difference will be zero, so that the current and voltage will be in phase with each other in this case. And we can simply understand from this waveform here, current will be, the magnitude of this current will be like this, because of the current will be given by dividing the resistance, dividing the voltage by resistance, so that this difference will be here. And the power in a pure resistance will be P is equal to V into I. These are the major things about this circuit when an alternating current is flowing through a pure resistor. Okay, thank you.